Standard form of an exponential function. Ready, go. Y equals a times b to the what? Power of x plus justice plus 2. Good job. So exponential functions look like this. Y equals a times b to the power of x. I see you. So y equals a times b to the power of x. Y equals a times b to the power of x. Well, what does a stand for? I know that we learned that. It's called the initial, yes, initial value. And it happens when x equals 0. Well, what really happens to a graph when x equals 0? When x equals 0, what does our graph really do, Caden? When x is 0, what does your graph really do? Ashton, what do you think? When x is 0, where is your graph touching? Like if I said the ordered pair is 0, 4, what is that a representation of? Not an x-intercept, but a y-intercept. So that initial value is your y-intercept. You guys remember that? It's the y-intercept, y-int. Okay. And then when we learned about exponentials, we said that the b value, that is our growth or decay rate. It's our growth or decay. And we're going to say factor. It's how much it grows or decays. So that's just kind of a reminder of exponential. And we just finished up with this fabulous unit on quadratic. So I know that everyone can tell me the standard form of an equation for a quadratic graph. Who wants the plus 2? Don't everybody fight to raise your hands at once. Y equals ax squared plus bx plus c. And do you know what the initial value is in that one, Violet? What does initial value mean? Initial value means where it crosses the, it's C. It's the ordered pair 0, C. So your initial value or your y-intercept, right, is the ordered pair 0, comma, C. Hopefully you guys remember that. Hopefully you remember that. We just did this. Okay. So today's notes are going to be really basic. The first thing that we're going to do is we're going to look at our functions and we're going to try and decide if they are representing a linear function, a quadratic function, or an exponential function. God bless you. Trying to look at it and see if it's representing a linear function, a quadratic function, or an exponential. And then we're going to kind of draw our curve or line of best fit, depending on our choice. So what about this first one, example A? It's exponential. And we just want to put a line of best fit in there. And remember that our line of best fit just kind of goes through the middle of the data points. So I'm going to do something like this. And I'm going to write exponential, because that looks a lot like the exponential curve right above me. This is exponential. What do you think about example B, Noah? What kind of curve or line of fit can we draw for example B? Your choices are linear, exponential, or quadratic. Yes, sir, quadratic. So we're going to write quadratic there. We're just going to try to put our line of fit kind of through the middle. Quadratic. Good job, Noah. All right, Amalia, I'm coming to you, okay? Look at example C. What does example C look like? Linear, exponential, or quadratic? Quadratic makes a U. Linear is a straight line. It's exponential. Good job. Remember that exponential functions, I'm going to kind of go back up to these graphs. Remember that as x gets bigger, either y gets bigger or y gets really small. So it rides this whole, like, remember how it rides along the x-axis, but it never goes below it, right? When we talk about a basic function. So when you think about this, it's kind of going like this, and then it's going to get really, 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 really close to that, right? And it levels out. That's what's happening. That's what exponential is. Well, it does if you put a number on the outside of it, like a plus or a minus after the function, but not the ax times b to the power of x. So does this first one, A, represent growth or decay? Growth. As x gets bigger, y gets bigger, right? But when we look at the one that Amalia just did, as x gets bigger, y gets smaller. So this is going to be decay. You guys are remembering some stuff. All right. Jansen, what about example D? What do you think example D represents? An exponential function, a quadratic function, or a linear function? Linear. Yeah, this is linear. Good job. Jansen, does that linear function have positive slope or negative slope? Good job. Negative slope. Which also means as x gets bigger, y gets smaller. Alrighty. Cameron, what about example E? Linear as well. Good job. Another linear. Cameron, does that linear function have positive or negative slope? Positive. That means as x gets bigger, y gets bigger, just like growth. All right, last one, Uriah, you're up. What do you think about F? Quadratic. Awesome. So those are our types of regression. Noah, say that again. You mean, did I say if it had positive or negative? I didn't, because that's a great question. Let's talk about B and F. Why isn't a quadratic function, why doesn't a quadratic function have positive or negative growth or slope? Because it does both. It does both. Remember, it has a turning point. Remember, it has a turning point, right? So it does both. That's why we can't classify it as one or the other, because it does both. What we say with a quadratic is that it's increasing, right? It shows increasing or positive until it gets to this point right here, which is called the vertex or the turning point. Do you guys remember that? And then it changes direction, yeah, and it starts to decrease. So when you look at the example F, is it increasing first or is it decreasing first? Yeah, you guys are awesome. So example F, it actually decreases first, decreasing, decreasing, decreasing. And then it gets to that magical turning point, right? Which is the vertex. And it changes direction and then it starts to increase. That's why we can't classify that. Excellent job, both of you. I couldn't have asked that question better myself. Perfect. Good with that? Do you guys feel okay with that? Okay. All right. So now we're going to start calculating some regression. Okay. So our calculators can produce equations for exponentials of best fit and quadratics of best fit, along with other types of curves. We're just going to worry about exponentials and quadratics. So example number 2 says biologists are modeling the number of flu cases as it spreads around a particular city. The total number of cases, Y, is recorded each day, X, after the total first reached 16. The data for the first week is shown in the table below. So if the data for the first week is shown, remember that X is the number of days, okay? X represents days. So it says, use your calculator to find the exponential regression. So that means we have to go to our little handout. And if you look at your handout, the first thing it says is to enter the data in the calculator lists. Well, the first thing that I want you guys to do is clear your calculator. So let's talk about how to clear our memory. So you're going to hit the blue second button. Everybody, calculator, blue second button. Then you're going to go to the plus, and you're going to hit plus, and it'll say memory at the top. And I want to press number 4, where it says clear all lists, and then press enter. You guys see that? We're going to clear all of our lists. Good. So that way we don't have some crazy list stuff going on like we did before. Okay. So second, plus. Sure it did. It says done. Number 4. Enter. Clear all lists. Hit enter again. It says it's done. No. It's not clearing your memory. It's clearing your stat lists.
Oh, okay.
Okay. Okay. So how do we build our lists? Do you guys remember? Okay. Well, we're going to go to our second stats. So second button, stat plot. It's right above the Y equals. Second button, stat plot. And then we're going to, maybe that's not right. Not right. That's to get our regression. Stop. Sorry, my bad. Go to stat. It's the button right below delete. It's its own little button, stats. It's like right next to your little arrow keys. You guys see the stat button? Yeah. And we're going to press number 1, edit. And I think it even says it on your directions. Number 1, edit. So all of our X values are going to be L1, and all of our Y values are going to be L2. We're going to just put our X values in, and then we'll go over and do our Y values. Does that make sense? Mm-hmm. So X values, 0, enter. 1, enter. 3, enter. 4, enter. 6, enter. 7. Then I'm going to arrow over to my L2. So stat. Number 1 is to enter. Put in your X's. L2. So, did you do your L1 yet? Okay, so do your L1 first. Right here. All your X's. Okay. I'm checking calculators. I'm trying to look and make sure you're doing what you should be doing. You already have your list built? Okay. Okay. Are we good? Everybody's got their list built? Okay, what does it say to do next? Look at your little step number 2. So we're going to hit the second button. Second, it says prepare for a plot, right? So press your second button. That's your blue button. And then the button that says Y equals, above it is the stat plot. That's what you want to get. We're going to go to Y equals. You guys see that? And then we're going to press our zoom button and hit enter, and it'll put our stat plot on there. We'll draw our little, mine is a regression line. Your zoom button right there. And then do. So you got dots. You got nothing, actually. I got a line. Yeah. Okay, that's all right. Go down to the next one. We don't care what the stat plot is. Go down to the next one. Hit second stat. Anyway, hit that second stat plot and just press enter. We're just going to go right to the regression. Okay. Do you guys see that? So if you go down and hit enter again, Will it draw your graph for you? After you hit zoom, then? I hate this. None of our lists work. Yeah. Okay, well, yeah. I have a dot, that's it. How did you get yours to work? Yeah. So we're skipping number 2. Some of you guys have a dot plot. I have a linear plot, and some of you guys have just a coordinate grid. Just don't even worry about number 2. Hopefully we don't have to look at our plot. I'll figure that out. Because why is it that the calculators, some of them, do we know? Like, I was talking to Lucy about that the other day. Some of them work and some of them don't.
Are some of them updated and some not?
Yes, because I have all the old ones. So that's all right. We're going to skip the whole step number 2. I'm crossing it off. I don't even care about it. Okay. We have our list built. Here's what I want you to do. Go back to your stat button and arrow over to the right where it says calculator. This is where all the fun stuff is. So the stat button, which remember is right by your plus, minus, equal, like your arrow signs. Do you guys see it? Arrow over 1 to where it says calc. We are going to do regression, right? And our question number 1 asks us for exponential regression. So do you guys see where if you arrow down, it says linear regression is number 4, quadratic regression is number 5, cubic regression is number 6, quartic regression is number 7. Number 10 is what? What does number 10 say? Exponential regression. That's what I want you to press. You see how we arrowed down to that calculator? So stat, calc, all the way down to number 10. Got it? And then hit enter. We're going to hit our list 1, arrow all the way down to where it says calculate, and hit enter again. Okay, 0. Number 10. Okay. Right there, and then hit enter. And then arrow down to where it says calculate, enter. Did we all find that? Okay, so we here says error. You don't have anything in this list. You didn't build that. You don't have anything in the calculator, right? When we saying that. Okay, now when you go to calculator, we're going to over to edit. We're going to go all the way down to number 10, where it says exponential regression. We're going to hit enter. We're going to bring it down to where it says calculate. There you go. Okay, so hopefully, I think I left my code down. Hopefully we've got some numbers, right? Okay, so remember we said our equation was y equals a times b to the power of x. So let's talk about what did you guys get for a? What did you get for a? Go ahead, honey, just go. What did you get for a? Well, we're rounding to the nearest hundredth, which is 2 decimals, so we need 3 decimals to work with. So 15.921. And what did we get for b? What did we get for b? 1.122. So when it asks us to round to the nearest hundredth, remember that the hundredths place is right here, the second decimal, and it's the number that comes after it that tells me to round it up or keep it the same. It's the number that comes after it that tells me to round it up or keep it the same. So if I were to write my equation, y equals, what is the actual value that I'm using for a? 15 point. Does this 1 make me round my 2 up or keep it the same? Keep it the same. So y equals 15.92 parenthesis. Let's talk about b. Does the 2 tell me to round the 2 before it up or keep it the same? Keep it the same. 1.12 to the power of x. That is our exponential function or regression equation that represents those data points, okay? So it says, based on the regression equation, God bless you, how many total cases of flu will there be after 2 weeks? Well, that's my X number. God bless you. Remember that X is the number of days. So how many days are in 2 weeks? Yeah, so you have to let X equal 14. You have to let X equal 14. So Y equals 15.92 times 1.12 to the power of 14. So you're going to have to go to just your regular calc so you can hit second quit. Second quit will get you right to your regular calculator. You're going to do 15.92, parenthesis 1.12, close your parenthesis to the power of 14. So what do you guys get? I get 77.8. What do you get? You need to go to the nurse? 77.8. What do you guys get? Same thing? Okay, so we should probably round that up to a whole number, right? So how many cases do you think they have at 2 weeks? We're going to say 78 cases. 78 cases. That's the number of cases per day, okay? Does everybody see how we did that? Okay. According to your model, by what percent are the flu cases increasing daily? So this is asking about a percent increase. This is asking about a percent of increase. So that means I have to look at my B value. And B equals 1.12. Now, I don't know if you guys remember when we did growth and decay, but when we tried to figure out our growth or decay model, remember for growth, we did 1 plus the percent written as a decimal. That was for growth. And if we did decay, oops, that looks horrible. When we were calculating decay, we did 1 minus our percent written as a decimal. Okay, well, it tells us that this is growing. So what did we do to B? We took 1 plus 0.12 to represent the growth. Do you see how 1 plus 0.12 models this? Or we could just take 1.12 and subtract 1 from it. So this represents my percent growth as a decimal. This is my percent growth as a decimal. I want it as a percent. How do I do that? How do I take my percent growth that's written as a decimal and turn it back to a percent? Well, let's work backwards. I'm going to slide over for a second. What if I said I had 25%? How do I turn that into a decimal? Well, what is a percentage out of what? So 25 divided by 100 equals 0.25. So if I want to work back the other way, I want to go back to the percentage. Instead of dividing by 100, I have to do the opposite, which is what? Multiply by 100. 0.25 times 100 is 25%. So if I want to figure out what 0.12 is, I want to figure that out. I have to take 0.12 times 100. And I get 12%. So this is representing a 12% growth. It says hospital officials will declare an emergency when the total number of cases exceeds 200. So on what day will they declare an emergency? Well, we're going to have to do some guessing, right? So let's just see what the numbers are at 3 weeks. So in 3 weeks, how many days is that? So in 3 weeks, how many days is that? Yeah, 21 days. So let's just put 21 into our equation. So remember, we're going to do 15.92 0.91, sorry, 0.92, 15.92, parenthesis, 1.12 to the power of, close your parenthesis, 21. Let's talk about what we get for that one. Just round it to a nice whole number. What do you get? I can hardly hear you. 100 what? 172 cases. Okay, we're getting close. What about when we let the number of days equal 22 days? Let's see, 15.92 times 1.12 to the power of 22. Everybody should be putting this in their calculator. Aiden and Violet shouldn't be my only talkers over here. What is that? What do you get, Matthew? Do that for us. Do that math. 15.92, parenthesis, 1.12, the caret, the exponent button, 22. Matthew's got it. Yeah, about 192.64. So I'm going to say about 193. Is that okay? So let's see. What about at 23 days? Who wants to do the 23 math? Lorenzo, you're up. 15.92, parenthesis, 1.12. And then you're going to use that little button that looks like that caret button, 23. How many cases? 215, isn't it 0.75? Yeah, so can we say about 216 cases? So on what day are they going to declare an emergency? When did the cases exceed 200? What was it, Tiana? What did you say? Or was that Tiana? Who said that? What'd you say, Tiana? Yeah, on the 23rd day. On the 23rd day, they declare emergency. On the 23rd day. Okay. All right. So regression is about finding the best version of the curve or line that fits your data. All right. So for this next one, we're going to do the same exact thing. We're going to go into our stat list. We're going to build our data, but this time we're going to find a quadratic model. This time we're going to use a quadratic model. So press your stat button. Press your stat button, right? Remember, that's the button that's next to your little arrows. You're going to press number 1, edit, and we're going to build our list. So you can just type right over your L1, right over your L1. So your X values, 35, 88, 110. We didn't skip direction number 1. We skipped direction number 2. What are you talking about? Is that what you're saying? Direction number 1?
I thought we skipped that. Up here.
Oh, no, 135 is after 110, 154, and 190. And then arrow over, God bless you, to your L2 and put all the Y values in your L2. God bless you. These have decimals, 9.32. God bless you. 2.63. Remember, you have to hit enter after every button. Okay? Please remember that. So 2.63, enter. 1.42, enter. Isn't there supposed to be a what? You're fine. You're fine. Just when we go to calculate it, your statistics, can you let me look at it and make sure it's listed L2, L3, 2.12, enter. And then 5.5. So do you guys have your data in there? Yeah? Enter. Build your list. Oh, okay. You're asking where to go next? Stat. Hit your stat button again. Arrow over once to where it says calculator, right? You're going to go down to number 5, quadratic regression. Down to number 5. Arrow down to number 5, quadratic regression. And then you need to go all the way down to calculate. Okay. So now hit okay, then the stat. Okay, we're looking perfect. Go down to number 5. Oh, right. So we're going to change this to list. So you see L2 is right there. L2. Second, L3. That's what yours are listed. Okay. All right, so we should get some cool numbers for that, right? Arrow down to calculate. Yes. So tell me what we get for our quadratic function. What do we get for our quadratic function? What is our a value? So if we were rounding to the nearest thousandth, let's round to the nearest thousandth. So if a equals 0.0010, what is a really going to be? 0.001. So 0.001 x squared. What is our value of b? Nearest thousandths. 2504. So this is what I want, 3 decimals. Does this 4 make me round that 0 up or keep it the same? Keep it the same. Plus, so don't put plus, put minus because it's negative. Minus 0.25x. And then what is our value of C? So let's do 4 decimals. 16 point what? 8629. So we want the third place, the third decimal. Does this 9 make me round that 2 up or keep it the same? Round it up. Plus 16.863. Okay. So it says, why should a quadratic model be considered for this? Why should we consider a quadratic model? Well, my outputs, my y values, this is kind of what Gianna said earlier. My outputs are decreasing. And then, right? So here they're decreasing. But then they get right here and they change directions and then they go back to increasing. So, and then they start increasing. And we know, so we know a quadratic is the only model or the only function that is both. It's increasing and decreasing. Quadratic is the only function that does that. All right. So we're going to kind of divide and conquer on the next 4 examples. So the A, B, C, D. So turn over to example or exercise number 4. We're going to do a divide and conquer. Okay. So example number 4, we're just looking at all of the X. Do you guys see that all of the X values are the same for these A, B, C choices? The X values are all the same. We're just going to compare these and see which one gives us a stronger R value. And I don't know if you remember when we did regression before, but your R is your correlation coefficient. So remember that your R value is your correlation coefficient. And remember, the closer it is to 1, the better the fit. Do you guys remember that? So we did like strong positive correlation, weak positive correlation. You guys remember that terminology? So we used our R value to decide if it was getting closer to 1, like if it was a strong fit or if it wasn't. Okay. So here's what, and and we're going to do this with a linear regression. So here's what I want to do. I'm going to do the first one with you, and then the BCD we're going to divide and conquer. So for the first one, go back to your stat calculator. Go back to your stat calculator. Press number 1, enter, because we have to edit our lists. So we're going to change our lists. The X values, once we input the X's, they're not going to change at all, right? They're the same X values. So 2, enter, 5, enter, 8, enter, 11, enter, 15, enter, 18, enter. Our X values aren't going to change for the rest of this activity. Our X's aren't going to change for the rest of this activity, okay? So we just need to change our L2, our list number 2, our Y values. So we're going to do example A together. 4, 13, 22, 29, 43, and 52. Okay. This one is asking us to find a linear regression. So we're going to go to stat, arrow over to calculator. And you're going to go down to number 4 where it says linear regression. Arrow down to calculate, and all you want is the R value, not the R squared value. We just want the R value. So what does R equal for this example? It says to the nearest thousandth, so that's 3 decimal places. What is R? Do you guys see your R value on your regression? Does everybody only have A and B? Does anyone have R? Okay, R values. I got 0.999. What'd you get? That's not true. I got 0.9989, which rounds it to 0.999. Okay, well, that's not right, I promise. So I'll do the next one in Desmos, because you guys do know how to do linear regression in Desmos. All right, so I'm going to pull up your Desmos and we'll do the next one in the next regression there. Okay, so if I want to put in a table of values, do you guys remember how to do that? Start with your plus, hit your table. So 2, 5, 8, 11, 15, and 18. I don't know why some of you guys have an R value and some don't. I'm going to have to troubleshoot that. 16, 14, 22, 41, 37, and 51. Do you guys remember the equation for linear regression? Instead of y equals mx plus b, it's y, the little squiggly, about ax sub 1. Like, you're going to do y sub 1, ax sub 1. Do you guys remember that? Plus b. And that will give you your R value. So for the second one, my R value is what? Yeah, it's 0.9301, ma'am. I put 51 instead of 52. Yeah, I'm on the first equation. I'm on the second equation, okay? So your R equals 0.930. So that's a good fit, but it's not very good. It's just a good fit. You can look at your points. Look at how your line goes through your points. Still pretty strong fit, right? Then I'm going to do the next one. Remember, I'm only changing the Y values. So example C, when X is 2, Y is 18. If someone wants to call them out to me, that would be super great. When X is 5, it's 8. Okay, keep going. Perfect. Perfect. So let's see what our R value is here. Ooh, Our R value here is 0.776. So for example C, R equals 0.776. So I would say that that's weak to moderate. Weak to moderate, right? It's definitely not close to 1. An example D, who's going to rattle off my X values for D? 44, 51, 30, 55, 45, 47. All right, let's look at that R value. Whew. R equals 0.133. That's not a good fit at all. It's not a good fit at all. Violet, what are you doing? Okay. So, do you guys remember how to do regression in Desmos? And you have the directions on the back of your paper. Okay. On the back of your handout, you have them. All right. We're almost done. Almost done. Okay. So, last example. Example number 5 says the following data set is that of two variables that have negative correlation. Enter the data, produce the scatter plot, and record the R value. How is negative correlation reflected in the R value? So it's the same X's as the last 4 that we did. So someone just rattle off those numbers to me again. For example, 5, if you don't mind. 52. 8, I didn't hear you. 47. Okay. 28, 32, 25, 10. Okay. So let's look at our R value here. It says our R value is negative 0.945. Our R value here is negative 0.945. But look at how closely our data fits. What does that negative R value do? What does the negative R value tell us? Do you guys remember? It's negative 0.945. It just tells us that the slope is negative. This means slope is negative. That's all it does. Just means that our regression line has negative slope. Is it still close to the absolute value of 1? Is it still getting pretty close to 1? Yes. It's really close to negative 1. This just means the slope is negative. So this is still very close to negative 1. So when you look at regression, if your slope is positive, you're going to have a positive R number. If your slope is negative, you're going to have a negative R number. So given this scatter plot right here, which of the R values would most likely represent the correlation between the two variables? Well, does this have positive or negative slope? It has positive slope. So first of all, that lets us eliminate number 4. Okay. Number 2, that 0.28, this has very, very weak correlation, right? So that's going to look like a snowstorm. We're going to barely be able to tell that makes a line. So do you think that example 2 represents that scatter plot? No way. What about example 3? Do these points form a perfectly straight line? Nope. This would be a perfectly straight line, and it's not. So that means that our only other choice is 0.88.